Now let's quickly implement the finding of a square root of a number using binary searching technique that we have discussed previously. Here I have written the class, I have written the function as well, and I have also written the code in the main method for calling that specific function as well. So here let's just quickly write the logic. So since we are going to use binary searching, let me just define start and int end. This end will be at most equal to the number, and along with that let me just define middle also. Now while as long as start is less than or equal to end, whatever we have, what we will do, we will calculate the middle. Middle is nothing but start plus end divided by 2. If at all this middle multiplied by middle is equal to the number that we have got, in this case obviously whatever the middle multiplied by middle is yielding the number. In this case square root of a number is nothing but whatever the middle that we have got here. So we will simply return middle itself. If this is not the case, what if this middle multiplied by middle is greater than this number, and the other scenario is middle multiplied by middle is less than whatever the number that we have got. So here if at all the multiplied result is greater than whatever the number that we have got, in this case what we need to do, the squared value of middle is greater than number. That means it will be whatever the square root of the number that we have got, it will be somewhere less than whatever the middle that we have calculated. So here to do that we will simply update end with middle minus 1. If this is not the case, what we will do, we need to find the square root. Obviously since middle multiplied by middle is less than the number that we have got, it will be greater than whatever the middle that we have. So we will simply update this start with middle plus 1. Now once we complete this while loop completely, right, for all the scenarios that we have got, if at all the number that we have got doesn't have a proper square root, let's just say if we are passing 4 has a proper square root which is nothing but 2, right? But if I pass 8 does not have proper square root. The result will be somewhere 2.8, something like that. But in that case also we need to return 2 as square root of that particular value 8 that we are getting. So to pass to handle those scenarios, I mean the scenarios where the number does not have a proper square root, in that case we will simply return start minus 1, because whatever the start that we have will basically be one value greater than what is the closest square root of that particular number. That's why here we will decrement it by 1 and we will return in the end. Okay, so this is how we solve the problem of finding the square root of a particular number using binary searching technique. Now anyway, here the number that I have passed is 5, and I have also called that function, and in the end I'm printing the result, right? And the output that I should expect is since the number that I'm passing is 5, right? 5 is somewhere after 4 square root is 2, so it should be something like 2 point something. So the closest number is 2, right? So the output should be 2. So if I run this code now, see the output that we have got is 2. Let's just say if I'm passing 9 is basically 3 square, right? So the square root of 9 is 3. So if I run it now, the output is 3. Okay, let's just say if I'm passing 11 is somewhere after 9, so it should be something like 3.1 something. So if I run this now, the output should be 3. Okay, so the idea of solving this problem is not to get the exact square root, but to get the closest actual square root of a number if at all the number does not have a proper square root. Let's just say if I'm passing 100 square root is nothing but 10, right? So if I see 10 is what we have got. Okay, so whatever the solution that we have written is working absolutely fine for all the numbers that we are passing. One more thing that you can ask, what about the negative numbers? The problem statement itself has mentioned that we will not be passing any of the negative numbers. That's why I have not written the code for handling any of the negative numbers. If at all, if you want to handle that also, you can simply put a check if the number is less than 0, and you can return whatever the appropriate value that you think is the good one. Okay, you can return any of the appropriate value based on your discussion. Anyway, I will not be writing the logic for that one. And that's it for finding the square root of a particular number using binary searching technique. You can go to codingpal.org and you can find the normal naive brute force approach solution as well on codingpal.org. Okay, so that's it for this one. I'll see you in the next problem.